In part 1 of this video, we looked at the factors that influence how much solar energy you're likely to produce if you invested in solar panels. To briefly recap, these were location, where in the country you live, number of panels, the size of your solar panel array, direction, which way your panels face, roof type and pitch, the angle at which your panels face the sun, and shading, how much and how frequently your panels are in the shade. In this second part of the video, we take a look at some online calculators to see how well they can estimate how much electricity you should expect your solar panel installation to generate in real-world conditions. In choosing which online calculators to consider, we selected two that we have personally used in the past, and one other found during a brief Google search using the phrase Online Solar Panel Calculator UK. We'll start with one of the calculators we have personally used in the past, which incidentally also appears high up on the Google search results, which is from the Energy Saving Trust. Before we make a start, we need to choose a location. In part 1, we used Edgbaston in Birmingham for the purpose of illustrating the difference in energy generating potential for north, east, south and west facing solar panels. So, we'll stick with Edgbaston and using Google Maps find a suitable property in the area that already has solar panels installed. By using this calculator, we should be able to get an idea of what size solar panel system is right for us, how much we could save on our electricity bills, and how much we could lower our carbon emissions. We should also find out how much it might cost to install our solar panel system, and a breakdown of how much money we could get from using the generated electricity and from selling electricity to the grid. If you're new to this website and calculator, it is worth reading some of the text content. However, if you've watched part 1 of this video, you'll already be familiar with the terms kilowatt peak and kilowatt hour, so let's move on. First, we need to enter the required postcode. Next, we'll specify that our panels are to be installed on a sloping roof. And then, in this step, we need to specify how much roof space is available. The options starting with a small mid-terrace style of house, typically accommodating 4 panels, up to a large detached house with sufficient roof space for 13 or more panels. For now, we'll select the small detached house option with roof space for 9 to 12 panels, although it was clear from the Google Maps image that the house in question had significantly more space and panels installed, but we'll return to that later. As we discussed in part 1, most UK roofs tend to have a pitch of between 30 and 40 degrees, so for now we'll retain the default midpoint value of 35 degrees. We now need to specify the direction our solar panels will face, as this will determine how much energy they'll generate and when during the day they'll output the most. Focusing on our example property, we first drag the map such that the centre of the compass pointer sits over the roof section of interest. Then, using the slider, we rotate the compass pointer to indicate the direction that the roof and hence solar panels face. Having done that, we see the direction is given as southeast. However, it's worth noting that the pointer is actually aligned with the third mark in the east to south quadrant of the compass. As each mark indicates 10 degrees around the compass face, we can deduce the direction is 120 degrees, which is somewhere between east-southeast at 112 degrees and southeast at 135 degrees. We'll see if this is taken into account in the calculation later, and indeed if it makes any significant difference at all. We're then prompted to specify whether the solar panels would be subject to any shading, with 4 different options from which to choose. Going back to the aerial photograph, it does look like there are some trees located to the south and east of the property, which might give rise to some shading. However, for now, we'll just assume that these don't cause any problems and select no shading. The remaining sections that need to be completed all relate to determining how much use of any solar generated electricity you are likely to be able to make. Although this will provide some useful information, as it isn't the specific focus of this video, we'll just select some reasonable options and then progress through to the end relatively quickly. For this purpose, we've assumed a 2-person household using gas to provide both hot water and central heating, though obviously you should specify the options relevant to yourself if you're going to get the most benefit from this tool. At which point, the system provides a summary of the answers and selections that we've made. And quelle surprise! It looks like solar panels should be suitable for us. At which point, we can go to the results, where we see that for a 4.5 kilowatt peak solar panel array on the property in question, we should expect to generate 3,600 kilowatt hours of electricity per year. Whilst we're not going to look in detail here at the other results the tool has generated, there are some figures where it would be interesting to know how they've been determined, such as installation and maintenance cost, amount of electricity exported, payback period, etc. We'll tabulate all the results from the different calculators later in the video. What we do like about this calculator is that it's very easy to use, with good explanatory text, and is thus ideal for someone completely new to solar power. The results can be saved in a PDF report format, which could be useful when progressing to the stage of getting quotes from suppliers. And there's no need to give your email address or contact details. Switching back to the results section, we see there's an option to change the size of the solar panel array. Selecting this gives us the option to specify either one of 4 predefined panel array sizes, from a tiddler of 1.5 kilowatt peak to something 4 times the size at 6 kilowatt peak, or alternatively to specify a custom size. Selecting the 6 kilowatt peak option, we see the electricity generated increases to 4,800 kilowatt hours, which simply reflects the increase by 33% from the previous array size of 4.5 kilowatt peak. Repeating this, but now inputting an array size of 8 kilowatt peak, which is probably representative of the example property, which had 21 solar panels installed, we see the figure for generated electricity increases again to 6,400 kilowatt hours, reflecting the 78% increase from the original array size of 4.5 kilowatt peak. For reference, we just used a nominal figure of £10,000 for the installation cost at this point. So there you have it, estimates of how much electricity our Brummie couple should expect to generate using the solar panel calculator from the Energy Saving Trust. In summary, very easy to use, and we would suggest a good starting point for anyone at the beginning of their solar power journey. Of course, this is just one of the many solar calculators available online, and this video would be very long and tedious if we went through each one in great detail. Instead, we'll just highlight 2 other calculators that you may wish to take a look at, tabulate their results, and comment on any specific features or points of interest. Before we do, a small request. If you're finding this video useful, please go ahead and click on the thumbs up icon, as that helps it reach a wider audience. And consider subscribing if you're not already. Thanks. The Solar Wizard tool takes a completely different approach to that of the Energy Saving Trust. Having entered the postcode and address of the property of interest, we are instantly presented with a summary indication of the solar potential, which is rated very good. Although our attention is perhaps drawn to the headline figure of 7,729 kilowatt hours, we should instead focus on the projected yield of 818 kilowatt hours per kilowatt peak of installed panel capacity. Simple multiplication will then give figures of 3681 kilowatt hours, 4908 kilowatt hours and 6544 kilowatt hours for panel array sizes of 4.5 kilowatt peak, 6.0 kilowatt peak and 8.0 kilowatt peak respectively. Although these results are slightly different to those seen earlier, they are within a couple of percentage points, and so either set of figures could be used to give a good initial working estimate of the probable electricity generation. So where do those big headline figures come from? Well, the tool has automatically identified 2 roof planes where solar panels could be installed, presumably from analysis of an aerial image, and indicated that roof plane 1 is the preferred option. With a predicted panel coverage area of 47.2 square metres, the tool suggests 9.5 kilowatt peak of installed panel capacity, which, for example, using 450 watt panels, would require around 21 panels. The estimated installation cost of nearly £18,000 is quite possibly well beyond the budgets of most households. But these figures are maximums, and as we've seen, it is fairly simple to scale the size of the system to suit your budget. Some interesting points to highlight include an aspect, i.e. the direction in which the panels face, of 120 degrees, which is what we suggested using the compass pointer in the Energy Saving Trust tool. A 54-degree roof slope, which seems unusually steep, but may well be correct, having looked at the Google Maps image. A month-by-month projection of the generated electricity, and an illustration of how the roof plane is shaded by other buildings, trees, or other parts of the property itself. In a similar manner as previously, projected costs and savings calculations are also presented, either based on default or user-specified selections. Again, this tool is very easy to use and quickly generates meaningful results with the minimum of user input being required, i.e. just the postcode and address. Some caution may however be needed when reviewing the headline figures, as discussed earlier. PVGIS, or the European Commission's Photovoltaic Geographical Information System, to give it its full title, is the final calculator that we'll look at. Although at first glance this tool may appear a little daunting and less user-friendly than those already reviewed, it is quite straightforward to use and allows more custom scenarios to be considered. An example of this might be if you are likely to have panels installed on roof sections facing in different directions, where it makes sense to calculate the electricity generation for each group of panels in turn, an east-west installation being a typical example. Exact values for roof pitch or slope can also be entered. Again, the starting point is to specify the property location, either by dropping a pin on the map when suitably zoomed in, or by specifying the latitude and longitude in the appropriate entry fields, which can be readily obtained via Google Maps. The panel array is then specified, in this case 4.5 kilowatt peak, and the roof mounted option selected. The remaining 2 parameters to be entered are slope in degrees, which for now we'll assume is 35 degrees, as before, and azimuth, also in degrees. This is the one aspect of the tool that can potentially cause confusion, as the azimuth, or orientation, is the angle of the solar panels relative to the direction due south. Thus, south, instead of being 180 degrees from north, would be 0 degrees, east would be minus 90 degrees, and west plus 90 degrees. Our earlier direction of 120 degrees from north, using the compass pointer, thus translates to minus 60 degrees from south. Clicking on Visualize Results then gives us a yearly energy production figure of 3,857 kilowatt hours, and a corresponding month-by-month projection. Interestingly, if we amend the roof slope to 54 degrees, as indicated by the Solar Wizard tool, and recalculate, the annual energy production drops to 3,691 kilowatt hours, which is almost identical to the Solar Wizard figure. However, this should come as no surprise, as the Solar Wizard tool utilises software and data from the PVGIS system. So there we have it, a quick look at 3 online solar calculation tools, all of which, by one means or another, give you some indication of how much electricity you should expect your solar panel installation to generate. As can be seen, each tool has generated slightly different results, and the impact of roof slope is quite noticeable. However, they are all very much in the same ballpark. Taking a simple average across all 4 columns, which admittedly may not be the most statistically valid thing to do, gives a nominal figure which is within 3 to 4% either way of any of the corresponding figures. This seems to us more than accurate enough on which to base any investment decision, particularly when you're at the early stage of your considerations. But of course, this is all fine and dandy. How do these figures actually stack up under real-world conditions? Well, for the author's own installation, a 12-panel 4.5 kilowatt peak system split equally across east and west facing panels, the PVGIS projected annual output is 3,329 kilowatt hours. Over the 24 months from August 2022 to July 2024, the actual total output of the system was 6,752 kilowatt hours, giving a yearly average of 3,376 kilowatt hours. So, the difference between projected and actual across a complete year was just 47 kilowatt hours, or 1.4%. That's good enough for me. If you liked this video or found it useful, please don't forget to click on the thumbs up icon, as that helps it reach a wider audience. Do consider subscribing if you're not already. It doesn't cost anything, and if you hit the notification bell icon as well, you'll be alerted whenever future content is released. Thanks for watching.